Hello and welcome to another screencast. This one's going to be on seasons. We're going to start the Earth off over here. This shows the Earth in its orbit around the Sun, which takes approximately a little over 365 days for the Earth to orbit the Sun completely. That would be 1 year. Over here you can see we have a little observer. Our observer is standing in the northern hemisphere, which means that this observer is north of the equator. Here is the equator, and then there's the south part of the equator. This would be the South Pole and the North Pole. Over here, here's your axes, and we have the North Pole here and the South Pole here. So this will show you the close-up of what's happening for our little observer as the Earth makes its orbit around the Sun. The orbit around the Sun is why we see a change in seasons throughout the year. We're going to start off at this position here. When Earth is at this position here, we can see that the northern axis is tilted away from the Sun, and the southern axis is tilted towards the Sun. So for an observer in the northern hemisphere, this would be the season of winter. We can see our observer here would have a very short amount of daylight hours as the Earth rotates, and longer nighttime hours. When I start the animation, you're going to see the Earth rotating, or spinning, as it orbits the Sun. Orbiting is also called revolution. So here we're going to start the animation. You can see that the Earth is rotating as it's also revolving around the Sun. From winter, the season that comes after winter would be spring. Here in Earth's orbit, it's in the spring, or we can call this vernal equinox. We call it an equinox because everybody here has, on Earth, we're saying here on Earth, has 12 hours of daylight and 12 hours of night. You can see that neither the northern or southern axis is tilted towards the Sun, so everybody's getting equal daylight and nighttime hours. The date for this would be March 21st or 22nd, depending on the year. And as Earth orbits, you can see we'd have April, then be May. This is really slow. Until finally Earth gets to the next important date, which would occur in June. During the month of June, we have the summer solstice. This is the first day of summer. We can tell that this is the first day of summer during Earth's orbit because the northern axis is tilted towards the Sun and the southern axis is not. And when we look at our little observer here, we can see that the daylight hours for our observer would be much longer during the summertime, which we all know that's what happens. We have longer daylight hours during the summer, and you can see the nighttime hours are much shorter. Earth then continues its orbit around the Sun. So we were here in June, then we have July, August. Now we're coming up on school time. In the month of September here, we experience the autumnal equinox, which is the first day of fall. This is about September 21st, and here you can see it's an equinox date because we have equal hours of daylight and equal hours of night as the Earth rotates. Finally, Earth comes back around to where it started. We had September, October, November, until finally we get to December. As we said before, in December, and it's about December 21st, we have our first day of winter. We call this the winter solstice. We can see again that the northern axis is tilted away from the Sun and the southern axis is tilted towards the Sun. So we have December, which is our winter solstice, about December 21st. Earth orbits the Sun. In the spring, which is about March 21st, we're going to have the vernal equinox. In the summer, this is the June, about June 21st, we have the summer solstice. And then in the fall, where we are right now, September 21st, neither the northern or southern hemisphere or axis is tilted towards the Sun. This is why we have equal daylight hours. And then finally, Earth completes its orbit back at the winter solstice. Both the tilt of the axes and the Earth's orbit around the sun is why we experience seasons, the change in seasons, and also why we experience the change in daylight hours. During the winter solstice, because our observer is not receiving direct sunlight because the northern axis is tilted away from the sun, we experience cooler temperatures. As the Earth moves into its summer solstice, we can see that our observer here is getting more direct sunlight and longer daylight hours, which would be the reason why we have warmer temperatures in the summer. Hope this helped you understand the beginning of seasons, and look forward to new projects.